Let's solve this problem. What do we have here? Here, the question asks that there is a vector p which is described as 3i plus 5j plus 2k, and we have to represent this in matrix form. So first, if I have to represent this in matrix form, I know that I have to write the four values. So I will write p as a matrix which is having four values. First is 3 for I, 5 for j, and 2 for k. And since this is not scaled, I will write that the scaling factor is 1. Now, if I want to write for the scale factor 2 as it's written here, the vector in matrix form with a scale factor of 2, then all I have to do is I have to write the scaling factor of this matrix as 2, and then each of the individual values I will have to write it by multiplying the original vector which is written here with 2. So 3 2s are 6, 5 2s are 10, and 2 into 2 will be 4. So you can directly see this vector p, and you can directly see that this has been scaled to a value of 2, and from this vector p which is scaled up, we can find out the original vector also. Now let's look at the third one, which is the direction. So direction is basically, we are only interested in the unit vector of p. That is what gives the direction. So I will write, I want to find p unit. So for p unit, I will have to find out, for p unit, I will first have to find out what is the magnitude of the vector p. The magnitude of vector p is going to be under root of 3 square, which will be 9, 5 square, which will be 25, and 2 square, which will be 4. Totally, we will get under root of 38, and that will give us an answer of 6.16. So how do we find out the vector p unit? The vector p unit is found out by dividing each of these values by the magnitude. So I will get 3 divided by, so 3 divided by lambda, then I will have 5 divided by lambda, and then 2 divided by lambda, and finally the scaling factor for unit vector is 0. So this I will together, totally I will get the answer as 0.487, 0.811, 0.324 with a scaling factor of 0.